Let's do one more example. So let's say now we have another function f defined piecewise, okay, which is x plus 2 if x is less than -1, x squared if x is in between -1 and 2, both extremes included, and then for x minus 4 if x is bigger than 2. And the question is, where is f not differentiable? All right. Now we have already seen that we have a formula, right? For x plus 2, x squared, 4x minus 4, we are able to find the derivative. So there will be no problem if x is less than -1 or x is in between -1 and 2 or x is bigger than 2. Okay, those three, no problem, because we already have a formula. So the only question now is you need to check x equals -1, x equals 2. Okay, so we need to find the lateral limits, or if you want, we need to find that the limit as x tends to -1, f of x minus f of -1 divided by x minus -1, x plus 1, and the limit as x tends to 2, f of x minus f of 2 divided by x minus 2, these two exist. Okay, when I say they exist, what I mean is the lateral limits coincide. Okay, so let's get to find those lateral limits. Let's start with -1. Okay, so we need to find the limit as x tends to -1 from the left and from the right. Okay, so there we go. Let's write down what is what. So f of x, when we are on the left, here it is, when we are on the left of -1 is x minus 2. And then the value when x equals -1 is given by x squared. So -1 squared is 1. Okay, keep that in mind. So this is x plus 2 minus -1 squared divided by x plus 1. Okay, but this is 2 minus 1. So we get, we get x plus 1 divided by x plus 1. So this is x plus 1. So this is equal to 1. Okay. All right. So on the right of -1, f of x is equal to x squared. We see it here. Okay. And the value of f of 1 is 1. So this is x squared minus 1 divided by x plus 1. So this is x minus 1 times x plus 1. So there's a cancellation. And we get -1 minus 1, that makes -2. So they are different. So that's it. The limit does not exist. Okay, the limit as x tends to -1 does not exist. And f is not differentiable at x equals -1. Okay. All right. So we still need to do the other limit, right? The other point, x equals 2. This is x equals -1, then x equals 2. So this is when x tends to 2, 2, 2, 2, 2, 2. There we go. You see we have 4x minus 4 if x is bigger than 2, x squared if it's smaller. Okay, smaller or equal. So let's use that information. Let's find first the limit from the right. Okay, so this is the limit as x tends to 2 from the right, f of x, which is 4x minus 4 in this case, minus 2 squared, which is the value we need to use for f of 2. Okay, then x minus 2, there we go. So this is, here we have 4x minus 2, right? Because it's 4x minus 8. There's a cancellation and the result is 4. Okay. And then when I compute the other side, x tends to 2 from the left. What do I get? 2 from the left. From the left, we have x squared, right? Minus 2 squared divided by x minus 2. That is x plus 2, x minus 2. So there is a cancellation. So 2 plus 2 makes 4. And they turn out to be equal. So in this case, the limit exists. Okay. And f is differentiable at x equals 2. Okay.